I'm Brian Pruitt, tutoring high school physics. Today's topic, kinematics, and also units and calculations. So before we actually do any calculations in physics, we have to know how units work in those calculations. First up, when adding or subtracting, your units have to be the same. If they are different, you have to be able to convert one unit into the other, otherwise you can't go through with the equation. So let me demonstrate. 5 meters to 5 kilometers. The units are different, but you can convert kilometers into meters and vice versa. Let's just convert kilometers into meters. 5 kilometers is 5,000 meters, so that's 5,005 meters total. Of course, if they were the same units, it'd be even easier. 5 meters with 5 meters gives us 10 meters. Piece of cake. But what if you have different units and you can't convert one into the other? Like 5 meters with 5 meters per second. That means you're a silly goose, and somewhere in your calculations you've made a mistake. Go back and correct it, and hopefully you won't run into that problem again. Alright, so next up, multiplication and division. Doesn't matter what your units are, they could be any units, but you also have to either multiply or divide those units. So let me demonstrate. 5 meters times 5 meters. 5 times 5 is 25, but you also have to multiply the meters together, so meters times meters is meters squared. What about 5 meters divided by 5 seconds? Well, 5 divided by 5 is 1, and meters divided by seconds is meters per second, which are quite literally meters divided by seconds. Okay, so on to kinematics equations. These are the three major equations you'll need to know for kinematics, and you'll probably want to have these memorized. It may also help to write out all the variables that are going to be in each equation. In fact, it may even help to write out all the variables throughout all of these equations to see if you can solve any one of them when you're starting out on a kinematics problem. Well, anyway, let's just go on with the first one. So, final velocity equals initial velocity plus acceleration times time. So in order to solve this equation, we'll need at least all but one of these variables. So final velocity, initial velocity, acceleration, and time. So let's say you have an object, and its final velocity was 15 meters per second. Let's also say that we don't know its initial velocity, but we do know it had an acceleration of 2 meters per second squared over a time of, say, 5 seconds. Well, that's enough to solve this equation. We have our final velocity, 15 meters per second, and notice that I'm writing out the units in the equation. This helps me keep track of them, helps stop me from making any of these mistakes and being a silly goose. Watch out, it can happen. So we come back here, 15 meters per second equals an unknown initial velocity plus our acceleration 2 meters per second squared times our time of 5 seconds. Okay, so nothing happening on this side of the equation equals our unknown initial velocity plus 2 times 5 is 10, and the seconds cancels out with the seconds squared on the bottom, giving us meters per second. And isn't that lovely how that worked out? We have meters per second on both sides of the equation. We subtract 10 meters per second from both sides, giving us our initial velocity to be 5 meters per second. And yes, meters per second is a measure of velocity. This equation worked out great. Okay, so on to the next one. Final velocity squared equals initial velocity squared plus 2 times acceleration times displacement, or delta x. Recall that displacement can be expanded out to final position minus initial position. And in writing out the variables, I've certainly done that, putting in final position and initial position. So let's say we have an object, and it has a final velocity of 25 meters per second, initial velocity of 5 meters per second, an unknown acceleration. And let's say that it finished 24 meters away from some object. How about, I don't know, anything. Let's say your house. And it started, let's say, 12 meters from that same object. Maybe it's your house. It's probably not your house. So anyway, let's start solving this equation. We're missing only one variable, so we can do this. Our final velocity, 25 meters per second, is going to be squared equals our initial velocity, 5 meters per second, also squared, plus 2 times our unknown acceleration times 24 meters minus 12 meters. Ooh, just barely had enough space. Okay, so let's start working this out. 25 squared is 625 meters squared per second squared. Notice that I applied the same operation to those units. And then we have 5 meters per second squared gives us 25 meters squared per second squared plus 2 times the unknown acceleration. 24 meters minus 12 meters is 12 meters. Okay, so now we can subtract 25 meters squared per second squared from both sides of the equation, which gives us 600 meters squared per second squared equals, well, now we can multiply this 12 meters by 2, giving us 24 meters times our unknown acceleration. And now we can divide by meters, which, neatly enough, cancels out one of the meters on top of meters squared per second squared, which will leave us with units of meters per second squared. So, we find our final acceleration after dividing by 24 meters on both sides is 50 meters per second squared. That's impressive. Okay, so last equation. displacement equals our initial velocity times time plus 1/2 times acceleration times time squared. So let's actually do a word column for this one, and let's say we have a runner, and he finishes 24 meters past the finish line. So 24 meters. We don't know where he started, but we want to. And he has an initial velocity of 5 meters per second. Took 5 seconds to finish the race and accelerated at a rate of 4 meters per second squared. Now, before we go any further, I just want to point out, I said that his final position was 24 meters. But in the problem, we said 24 meters past the finish line. So what I'm saying is that the finish line is going to be on a plane, our 0 meters. Everything past the finish line will be positive, so positive 1 meters, 2 meters, all the way up to 24, where our runner has finished, and everything behind that finish line is going to be negative, such as our starting line, which we're trying to find out. So we're going to receive a negative answer for this particular equation, but that's okay, because that's what we want. So let's go ahead with this. We're actually going to have to expand out displacement here. So we have our final position, 24 meters, minus our unknown initial position, equals our initial velocity, 5 meters per second, times our time, 5 seconds, plus 1/2 times our acceleration of 4 meters per second squared, times our time, 5 seconds, squared. So let's see, nothing happening really on this side of the equation. 5 times 5 is 25. The seconds will cancel out, giving us meters. Plus 1/2 times 4 meters per second squared gives us 2 meters per second squared. 5 seconds squared gives us, 25 seconds squared. Let's keep going. 24 meters minus our initial position equals 25 meters plus 2 times 25 is 50 meters per second squared times second squared gives us meters. Alright, this is working out very nicely. Everything is coming out to be in meters. Now you subtract 24 meters from both sides of the equation, and we have 51 meters. Negative initial position is 51 meters, so we divide by -1, giving us negative 51 meters. And so that means that our initial position, our starting line, was in fact 51 meters behind the finish line. Alright, to recap. When working with units in equations, you can add and subtract units that are the same, and if the units are different, if you can convert one unit into the other, do so and then continue with the equation. Otherwise, you are a silly goose. Go back and check your calculations for a mistake somewhere. When multiplying or dividing, it doesn't matter what the units are, but you'll also have to do the same operation on the units. So there are 3 major equations in kinematics. First up, final velocity equals initial velocity plus acceleration times time. Next, final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. And finally, displacement equals initial velocity times time plus 1/2 times acceleration times time squared. When solving these equations, it may help to write out all the variables in those equations and then fill in the blanks. Remember that in order to solve any of these, you'll have to be at least missing only one. Alright, well that's all for now. Again, I'm Brian Freer. See you next time.